Winter, were you guys tenting or
We were in
oh
front of
nice.
the engineering
You guys talk to
video,
anyone
so
or
yeah, we got
yeah,
a
okay,
few
cool.
people that wanted to join.
Nice, nice, nice.
hmm A minute, and then we'll go ahead and get started.
I pressed record for the time being. Um, can y'all hear me okay?
Yes, a
Okay,
little
sweet.
laggy, but you're good. We can hear you.
Okay, sweet. Okay, okay. All right. Jesus Christ. Before we move forward, I just want to answer Bertrand's question, or was it Winston who asked about the VLLM?
Yeah, they were asking why it was more efficient.
Okay. So the reason it is more efficient is because it can take, first of all, it can take more concurrent requests. Um, and because of the way they built it, it is much lower level. So the throughput actually takes significantly less time, making it much faster and more efficient to use in a production setting.
Um,
Um, so
So they process the LM file, the computations better somehow.
correct, yes.
I see. Thank you.
Um, so the di main difference is Olama uses continuous batching, batches all the jobs one after another, but in VLLM they use something called paged attention. So it pretty much shifts focus to what is more important and what is heavier. And because of that, they get some amazing, uh, what do you call it? Performance leaps. So, I just searched it up to tell you like the actual numbers.
Uh-huh.
Um, when you look at it, on similar hardware, Olama peaks at
Benjamin
41.
Lopez, hello. What's up?
Hello, hello. Uh, so the Olama caps at 41 tokens per second. VLLM peaks at 793 tokens per second.
Sorry, what?
Uh,
Is it that
did I
big
cut
of a
out?
difference?
That big of a difference.
That is
So,
Wow.
huge, bro.
yes.
What were the numbers again?
It's like
Um,
40 and 790.
41 and 793.
What?
And then the P99 latency is 80 milliseconds versus 673, which is pretty insane. It's pretty insane.
Dude, it's got to be like at least 10 to 20 times better.
It is. It is a little tougher to set up, I'm not gonna lie, but it's worth it.
Yeah,
It's really
that
worth it.
sounds worth it.
And guys, come on, I'm not a professor. Thank you. Thank you though.
All right, yo, Serge, can you
Let's
start?
start.
Yeah, yeah. Can you share your
Uh,
screen real quick?
do I share my screen or do you guys want to do the slides and then I'll share my screen for the
For the
thing?
coding part? Jason, can
Yes.
you open it then? If that's cool.
Yeah, I just thought it would be a little easier if you did it, and then that way, like, you can just switch over really fast to
Okay,
the
sounds
coding
good.
thing.
Sounds
Yeah,
good. Sounds
okay.
good.
I was thinking
Let me
that too. I
just
was
open
thinking
it
that
up.
too.
All right, all right, okay, let's go. Right, let's get it, everyone. Whoop, whoop.
All right. I'll start us off then. All right, cool. Today we're going to break down how modern AI agents actually work under the hood. Most people interact with large language models through simple prompts, but what's powering real AI systems today isn't just prompting, it's structured reasoning, tool usage, controlled execution loops. So tonight we're going to understand that architecture conceptually, and then we're going to build a minimal version ourselves so you guys can see how it behaves in real time. So slide one right here, from prompts to intelligent agents. What most people do with language models is single shot prompting. You give it a question, it gives you an answer. That works when the answer is already inside the model's training data, but it breaks when you need math, external data, database access, search, and multiple step reasoning. A language model by itself cannot execute code, access APIs, or verify information. It can only predict text. Agents solve that limitation basically. And an agent introduces structure. It allows the model to reason, use tools, observe result, and iterate before giving a final answer. That shift from static response to dynamic reasoning is what enables automation. So yeah, as we can see right here, right? Traditional language models usage single prompt, single response. I kind of just gave a little breakdown of how it works and the comparison side by side. So we can go into the next page right now, or the next slide. All right, what is ReAct? ReAct stands for reasoning and acting. I just learned that like a few days, like a week ago, by the way. I got it confused with like the more high level React or like, there's a whole like React for like making apps and stuff that I got it confused for. But it's basically a structured prompting pattern that forces the model into a disciplined loop. Instead of jumping directly to an answer, the model generates a short thought. Then it decides whether it needs to perform an action. That action calls a tool, and the tool returns an observation. And only then does the model continue to or finalize. This structure reduces hallucination because the model must ground itself in tool outputs rather than guessing. The key idea here is control. We're not making the model smarter. We're constraining it into behaving intelligently. So yeah, like now let's look at how this actually works architecturally. So if we can go into the next slide. All right, under the hood, agent architecture. Here's the important part. The language model does not execute tools. It generates structured text that follows a format. We then parse that output, determine whether it requested a tool, execute the tool externally, and feed the result back into the model. So the intelligence emerges from orchestration. Basically, there's an order of operations to this. There are five moving parts. The prompt defines behavior. The tool registry defines capabilities. The controller loop manages execution. The parser interprets structured output, and the tool executor returns real-world data. The model is just one component. The system design is what makes it an agent. This is why agents are engineering problem, not just a prompt trick. So yeah, so now let's compare this to other common techniques. So if we can go on to the next slide. Yeah. All right, slide 4, ReAct versus other techniques. That encourages, or you may have heard of chain of thought prompting. I don't know if you guys are familiar with that. That encourages internal reasoning, but it doesn't allow tool use. You may have seen function calling that allows structured tool invocation, but often without iterative reasoning. You probably heard of RAG, retrieval augmented generation. I always mess that up. That injects external documents into context to improve factual grounding. ReAct combines reasoning and action in a loop, and modern production agents typically combine ReAct, RAG, tool calling, and memory into a single system. what we're building today is going to be like a minimal core that powers all of that. So and now that like we understand the architecture, I guess conceptually, let's build a simple version from scratch, and then Soroush would take it from here. Or actually, I think Jason's going to take it from here. Uh, and then thank you guys. Yeah.
Oh, it is me. It is me. Whoa. Okay. So, let me share this really quick. Okay. Can you guys see my VS Code window? Everyone? Yes. Okay, sweet. All right. So, to begin, thank you, David, first of all. I would like to give a little bit of context on a couple of things. The reason I think React is very special in the modern world, especially the way we're headed with AI, is because if you look at a lot of the tools that are coming out right now, Codex, Claude Code, Claude Bot, all of these are basic large language models that are equipped with some tools that we simply don't have in the beginning or when we start uh, using the chat function of a large language model. But it adds up to be this complex and useful little thing that is really lovely. And we're gonna demonstrate it with a tiny little demo today and hopefully work on it next week with more control over it. So I would suggest before we begin for everyone to create a uh, virtual environment and have any choice of editor. I chose VS Code just for the simplicity, but you can genuinely just use whatever you feel like it. Let's see. Okay, so I would first create a folder and call it server. I will also need a folder for client, a file for our environment variables, and I guess we will have to put a requirements.txt as well, but I will do it. Okay, so now for the sake of time, I'm not going to walk over how to install the packages and how to do the virtual environment. However, it will all be included in the GitHub that we will post after the meeting with the recording to ensure everybody is well equipped to redo everything that we're doing right here. The only thing I will do is in the virtual environment or in the .env file, I will type in the way we
So
are going
remember all
to.
the stuff I'm telling you right now.
What happened? Did anyone talk? Okay, all right. Let's see. So open AI API key and nice. We just fork and will there be a README for what packages we need? Yes, yes, Benjamin. Everything will be included, so you guys don't have to worry about literally anything. Everything would pretty much be a plug and play. Yes, sir. Okay, so these are the fields that we will need to have in our .env file. For the sake of not losing my credits on OpenAI, I'm gonna blur this real quick. I'm not gonna show you my API key, guys. I'm sorry. No free API keys. Uh,
So sad.
there we go. Okay, so now that that's out of the way, I just pasted values in front of those. We can get started with the actual coding part. So, first things first, inside of the server, let's create a, why am I yelling? app.py. App.py over here, and let's start with the imports. Nothing too special. We're going to import OS. Well, OS. We are going to import JSON because JSON is awesome. From typing, import any dictionaries, list, and optional. And I guess we go to the more technical ones now. We go from .env, import load.env. From fast API, import fast API. From import base model. From OpenAI, import OpenAI. Okay, so before I even begin the coding, how many of you guys have used these packages before? Nothing. I have not. Jason hasn't. All right. None of them? Jason, really? Okay, David has. Winston has. All right, all right. Okay, so Bertrand has not. Okay. I will explain why we are using OpenAI for this and not anything else after we're done. It has a connection between next week's workshop, which I think you guys would love actually. So let's create our config files first. So let's do OpenAI model to equal, we do os.get env AI model, or we do GPT-5 mini, something like that. And let's see. I'm going to copy these config files for the time being. And let's just create our OpenAI client. Whoa. I'm giving stuff away. Whoa. There we go. Okay, so this initializes our OpenAI API, making it accessible for us to send API requests to OpenAI, use their model, and then get something in return. Now, what we are going to work on today is sending a package to our large language model with custom instructions. For example, what we're going to talk about in ReAct is giving tools, correct? We're going to equip the model with some tools. What are these tools? Instances that we're going to walk over today is about capitals of certain countries or popular places or some other cities in those countries. So although this is very simple and your large language model probably knows this, the reason we're using this as an example is to show how much you can shrink down the knowledge base of a huge large language model to fit exactly your needs. So the way we are packaging our prompt with a set of instruction, which is the set of instructions with some function and the inputs of that function. We send this over to the large language model, After this detects that we are going to have, we might be needing to use one of these tools. For example, oh, I know where to get the capitals from. Google Maps, for example. And what it will do is call the tool, feed the prompt into it, get the result, goes back to the LLM. LLM processes it and gives it back to you as the user. Any questions so far? Everything clear on what we're doing? Or did I explain a little fast or a little unclear? Any questions?
This just initializes the model only, right? As of what we've done so far.
Yes, correct.
That sounds good. Thank you.
All right, awesome. So let's continue then. So again, for the tools, I'm going to create it statically, meaning I'm going to give all of these, make these like dictionaries or inline JSON files. And we'll do France, Paris. Actually, Japan, Tokyo, United Kingdom to be London, and let's say Land of Freedom. Someone play the eagle sound effect. Okay. Now we have our capitals. For the sake of it, I'm going to copy a couple of things so we don't lose time here. Take a look at these. So these are pretty much just maps. String to string, string to string, string to string. And then we have string to a list, string to list. Same here. And in other cities, we also have string to list. Okay. Any questions so far? Again, nothing too crazy so far, I would say. I will copy this. I am not gonna type in a whole JSON, but I will explain line by line for you guys what we're doing. So let's copy tools over here. So this is the custom. This is what the model is gonna know. This is how the model is gonna navigate through each of these functionalities that we're gonna give it. What do I mean by that? Example, the first function that we have here is, or the first tool we have here is a type function. What's the functionality? It gets the capital city of the country you asked it. As you see in the description, get the capital city of the country. It returns a type of object. What is the object? Country, type, string, description, country name. And what is required for this to happen is the country. If we go down, we get popular places, which is in a very similar situation and structure because it's also a function. It retrieves the favorite places or popular places from this list over here or this map over here. And same thing happens over here with other cities in the country. Okay. All right. Take a good look at this and let me know if you guys have any questions, because we are actually going to write the Python functions for these to work. Okay. All right. Moving along, let's make the actual functions. So Python doesn't understand this. Python doesn't know what the heck's going on here. So we're going to have to create all of these functions manually. Get capital city, country, and you don't need to declare your types over here. I rather do them because better be safe than sorry. I am a C# developer, so I'm used to declaring types. Although you can also do any or variable in C#. That's just... So let's see. Okay, we're retrieving the capital. So we do capitals. Whoa. Whoa. Capitals dot get country dot strip and dot lower. So no matter how they type it in, we can use it this way. And we do unknown, not in our demo dataset. Very simple functions. And we're going to do literally the same thing for the other ones. So def get popular place. Place is city of type string. Returns a string. And here we will do places equals other cities dot get. Oh, I'm sorry. Popular places dot get. And here we do city dot strip, same thing, dot lower. And otherwise, we will give it an empty list. And then we return a comma dot join places if places else we will return unknown, not in our demo dataset. Okay, and I'm just going to copy this and paste it for the other one. Get other cities in the country. Okay. Now, after we have these, we have to get started with actually making the server itself. So, I will add one thing before we continue. Tool functions to equal define them as get capital city to map to lambda. KW, get capital city, KW, country. Okay, before I continue, I would like to ask you guys, do you guys know what the lambda function is doing over here? Can anybody tell me, or any guesses even? Bertrand is not sure. That's okay. Anyone else? Okay. So we write it this way to declare something called a anonymous function. So anonymous function in KW stands for keyword. So we are saying this function right here maps to an anonymous function that calls or gets capital city and feeds it the keyword country. I will tell you why this becomes handy because sometimes when you think about it, the large language model might not return to exactly what you want, but it will also return something in plain text. It's not a function call that it will return. Does that make sense? So every response that you're getting from your large language model seems like the left-hand side text is a prompt. Not wrong, not wrong, not wrong, but almost there. So, the thing is, right? Oh, okay, okay. So the thing is, the reason we're doing it this way is what we're getting back from the large language model is going to be a formatted string or what we call a JSON. There's no function call in there. There's no call the function, parentheses, variable inside, close parentheses, and then runs it in Python. No, that does not happen. What does though is it gives us plain text. So we're going to look for every one of these function calls and use them to our leverage. Does that make sense? Okay. Now, since we have those, I'm going to
So it's basically an adapter, right?
pretty much an adapter for the string output that you get from the large language model for the tools that we defined up here, or the functions that we defined up here, and the tools. So,
Got it. So it like
uh,
bridges the format.
pretty much, yes.
Got it. Okay.
Yes. Okay, now I'm going to write a cheeky little prompt. Just a tiny one. Nothing too fancy. Because what lays in here, what is important is the tools itself. So you're a helpful assistant that can use tools. Let's name it, shall we? What do we name it, guys? Anyone has an idea? Give me a name. Jim Bob, fool, I don't know how to pronounce that. I'm not gonna lie. Oh, Grant. Okay, Jesus. I was like, whoa. I'm being racially insensitive right now. I'm sorry. I'm sorry. I'm sorry. Okay. Let's Grant or Jim Bob. We'll call him Grant the Jim Bob, and let's get a last name. Junior. Okay. Well, Grant the Jim Bob AI Junior. Let's do that. I like that. I like that. Grant the Jim Bob AI Junior. Very basic stuff. So when you need an external information or computation, call one of the provided tools. Prefer tools over facts, lookups, and calculations. If you don't need a tool, answer directly. Just for the safety measure, this is not needed. It is preferred for you to use the provided tools. Important. Use tools only when needed. Do not fabricate. Actually, I'm going to take this out and add this one in instead. Do not fabricate tool results. If user asks for a destructive action, delete, overwrite, etc., refuse and explain. This is very bare bones, but what you hear a lot of times from people using agentic AIs is this was big when like Cursor came out initially. People were like, "Oh no, Cursor deleted my whole database. Whoa, who would have seen this coming?" Because you never told it not to. You gave it full access to the database. So if it thinks it's unnecessary, it will delete it. That's how it goes. You give it full access, that's gonna happen. So same thing happens with a simple thing as like getting the countries, right? So the basis is important. It is very, very important for you to declare each of these rules in the get-go, in the prompt. Okay, so this is also important for you guys to realize. I feel like a lot of people don't know how to do the prompt. And there is a Google there's an article from Google that I hold pretty close to my heart at this point. It came out last year. It is very updated. It tells you how to actually communicate with a large language model to get effective results. And I think if you guys go by the rule book of Google itself, you guys can get amazing success. You don't need to be overly explaining of what it is, and you don't need to be overly simple with it. It has to be precise. It has to include everything that you need it to include, and it needs to understand it in order for it to not hallucinate. Hallucination is your worst enemy when you're working with large language models. Okay, so main function now. We're almost there. We're almost there. We're almost there. Oh yeah. Wait. Okay, there we go. All right, so I'm going to create a function called run agent. So this is where the agent starts running on your screen and then jumps out of your laptop or computer. I swear, guys, I'm not 73. that was just a horrible dad joke. I'm just trying to see if the people are awake at this point. Optional. Yeah, that's what I'm saying, dude. It was so funny. It was so funny. You guys don't understand the levels. I'm kidding, by the way. Kidding. For the sake of demo, I'm going to set the maximum steps to 6. Well, this is default parameter. Obviously, we can change it on the call itself, but I'll explain what this is momentarily when we actually get it to run. Okay, so we're taking in two things, the message of the user and the history of the chat. If anyone here attended the workshop last week, we talked about large language models being stateless beings. So what you input in this box that is large language model is just an input. Oh my God, there we go. Okay. So the input that you give to the large language model will always have one output, and that's it. That is it. That's how large language models work. But then it raises the question on how do large language models, when you chat with them, know the context of the last message and the message before that and 10 messages before that? Does anyone know? Briefly.
The whole conversation gets repeated.
Bingo! The whole conversation gets fed into the large language model again. So that's why when you're talking on a thread with ChatGPT for like 7 hours, the 8th hour he starts tweaking. Legit tweaking because it just has too much in it. It doesn't know where to stop. It loses context awareness and it loses its ability to think within the context you want it. You're continuously feeding it repeated conversations. Uh, Speaking from real experience, absolutely, yes. Yes. Yes, Amanda, yes. I am not proud of it. I've had very, very long conversations with AI, mostly coding, but I've had very long threads. And it's gotten better. It's gotten better. But it's still there. If you look at Gemini, ChatGPT, whatever the case is, all of them have this problem. All of them go through this issue. All of them have this problem happen. Okay, so let's see. Before I continue with the function, I would like, Jason, are you here?
I am here, yes.
Okay, so before we continue, do you want to go over the importance of the prompt and the tools that we define from the slides?
Um, yes. I'm not gonna lie, it's kind of just a refresher of what you had, and
Okay,
I kind of just did more of an explanation of everything.
okay,
So maybe I can save it towards the end, and then I can
sure,
refresh everyone.
sure, sure. That sounds
Yeah,
good. Sounds good.
yeah,
Just checking.
that's it.
Okay. All right, then let's get this started. Um, okay, so I'm gonna copy these and explain line by line what the heck's going on here. Messages is maps to lists. It maps to a list of dictionary that has the type of key value string in any. This equals to role, system, and then content is your system prompt that we defined up here. Okay. If there is any history, we extend the messages that we have over here to include all of the history. Or for now, we're doing max steps, which is like 6. Then messages.append role user content and then the message of the user at the end. So it will include all of the context of the chat with the new addition of the user's message, the last message. And let's see. Okay, so I'm going to type these manually because I want to explain. So we're going to have a trace as an empty list. And for every variable in range of max steps, what I'm going to do is response resp equals our client dot what was it, chat dot completions dot create, was it? Yes, dot create, and here we will give it all the parameters that it needs. So model to equal, let's see, model. Oh, we don't have an OpenAI model, I guess. And then messages to equal messages. Who would have thought? Did any of you guys guess that? Seriously? Tools to equal tools. Tool choice to equal auto. And temperature to equal, I'm gonna say 1 for now, but we'll talk about this. Does anyone know what temperature is in a large language model? The degree of randomness. Yes, Catherine. Yes, Bertrand. Yes, yes, you are both correct. It is pretty much the amount of randomness that you allow the large language model. In cases where you are doing, uh, uh, you're asking your large language model to do something that you want it to be almost exactly the same thing at all times, is going to be closer to 0. And when you have a situation where you need to uh, have it be more creative, you get it closer to 1. Okay, so tool calls equals get attribute, message, and tool calls, and if tool calls, if the large language model returns anything for us to work with tools, TC in tool calls, what we're going to do is tool name, separated, equals tc.function.name. The arguments are going to be json.loads, tc.function.arguments, or, whoa, my bad. Simply just an empty dictionary. And the result is tools, tool funcs, tool name. We call the tool name. And we pass our arguments. Okay, so note these are the lambda functions that we just created up here. We're passing the argument that we got from a JSON as a empty text. Oh, whoa, plain text, not empty. Plain text in here as arguments. And if tool name is in tool functions, otherwise we say unknown tool name. Okay. Trace dot append. Now we're going to add everything to our trace. What are we adding to our trace? You may ask, what is the tool? What are the arguments? And what is the result? After that, messages. Dot append role let's see, assistant. My spelling's not great, guys. I'm sorry. Message dot content or empty if it's nothing. And tool false to be AC. Now I'm going to do something very similar. I'm not going to type that. Nobody saw that. Nobody saw that. We continue. Okay, so the final message is going to equal the message msg dot content or an empty string. And we return at the end the answer to be our final string. What we parse out from the thing, the trace to be oh my god. Not only I can't spell, I can't type either. Messages, and we'll do -8 something. This, okay. After this, app equals fast API title equals. What did we name the guy? Grant the Jim Bob AI Jr. himself. On God. I don't know, man. And we initialized the web app. I guess I never explained what Fast API is. I'm sorry. So Fast API is a library just like Flask that allows you to create web applications through Python. It is significantly faster given the name, just because of the name, not because of the code itself. No, but on a serious note, it is faster and it gives you more functionality on a actual enterprise level. If you're using this for something enterprise, it is is going to be far better than Flask. Now, Flask has abilities that Fast API doesn't. For example, linking it with HTML and having building actual websites with it. However, with Fast API, you can create endpoints for your APIs or make internal, external APIs for your application whenever you have it. Just for the sake of it, I'm going to create a class called chat. Is there anyone here that does not know what a class is? Okay, I guess we are good. Okay. And then let's move the final part. Post. So see, this is very similar to Flask, for example. It allows you to create a function and give it a route. With a post, meaning that when you are sending an HTTP request or a web request per se, to an endpoint, there are different types of requests. Get is always retrieving data. Post is pushing data to your endpoint. There are other things. Put, there is a couple things that I don't remember and no one really uses, but the main two are post and get. So here we're creating a post because we're giving the information to it. We'll call it body. Chat is a type of chat in. And at the end, we return body.message. Do we? No, my bad. Let's do run agent. I'm sorry, run agent. We give it body dot message and history to equal body dot history. Okay, so the only reason I'm doing a class over here is because we can take in a JSON, a object as input, and then parse it through here, if that makes sense. If you guys see up here, we defined this as a string, user message as a string, and history as a list of dictionary with type string and any. Okay, any questions? Everyone clear? Before I move on.
Where does the output spit out to?
Haha. Thank you. Thank you for asking that. Currently nowhere. Currently, when you do this, it will be into Abyss. But I created the client folder over here. Well, not a folder. I created the client folder over here to create a CLI so we can see it in action in terminal. So given this URL, I'm going to give it the object and type in the message inside of our terminal. Okay, so give me one moment. Assuming that I'm going to switch to this one. It's the exact same code, but I'm going to switch to this one really quick. Can you guys still see the screen? Yes, okay, sweet. So, here we go. Okay. Now, for us to be able to see it in the CLI, we will have to run two instances of terminals. So I'm going to see if I can separate this. Okay, there we go. So on one part, what I'm going to do is run my CLI. I don't think it will work before I do that. Actually, it does. Now, to show you how it works, if I right now type in this hello, it will time out because I don't have the thing posting. See, it messes up. But what I do have is our best buddy app over here. Now, when I run this and run the CLI again, we can start typing and hopefully, fingers crossed, it should work. I've tested this last night and it did work. Yes. Hello, how can I help you today? So this is just a regular command line interface that we are going to use. And I'm going to say, what is the capital of USA? And in theory, it should use our tool to give us back the information. Okay, now you guys might be thinking, hey, Surush, but the LLM could have done this already without us asking. You're correct. You're not wrong. You're absolutely correct. Where this matters is in complex applications when you do not use these. You ask it to log into GitHub and push a make a PR request. Or when you connect it to Discord and ask it to post a message in your chat or in a server. Example, if I now ask, what are some popular places in London? There are two ways this will work. How many of you guys think this will work? How many of you guys do you think it's not going to work? What's the basis of it working? Why doesn't it just skip over what it should be? Why doesn't it just use its own LLM information instead of using the tools that we gave it? Because we prompted to. Now I'm gonna resume to the share again. I just wanted you guys to see. It gets more informative. It gets more informative. But if you see, I asked what are some popular places in London, and it gave the exact same list of places that we have over here. The British Museum, Tower of London, Westminster, Ba- Borough Market, Hyde Park. It just used its knowledge to give more context on each of those. Isn't that cool? Isn't that cool? Or I'm a nerd. Uh, I would love to show you a source code of this. Not this, but what I'm going to talk about. But I can't. It's under conf confidentiality. But one of the things that I'm building at work, for example, is a AI phone system where you know how you call, for example, Bank of America, and there's an AI that you can talk to, and some of them are very advanced. You can have full-on conversations with, and they don't hallucinate. They know what you're talking about, and it's not just like the one word, I want to talk to someone. And it continues to repeat itself. It's not a one sentence or key doesn't look for keywords. The way that works is through a tree of knowledge. For example, it looks for the keyword app, and then it routes you to somewhere. If it gets an answer of like yes here, if you've signed up for the app, yes, it goes somewhere else. If the answer to the next question is no, it does something else. But that is what we call a tree of thought, where you give it all of the instructions that you needed from the get-go, and it will just judge based on that tree. It can only respond based on that tree. What happens with these is there's no large language model. It's the continuously same sentences repeating over and over based on what you tell the system. A lot of chatbots even still use this, older chatbots in mostly government websites at this point. But with ReAct, you're able to create unlimited amounts of randomness in conversation within your desire, within your context. So if you, for example, in the prompt say, hey, my company's name is I don't know, Grant Jim Bob LLC. And we sell the AI models that run off of screens. See, I ran the joke again. No, very funny joke. So you guys don't fall asleep and you're like, oh my God. I gotta keep it a little disgusting, you know? You give it context. You give it context. You give it context in order for it to understand what is going on, know your business. And when someone calls and asks, hey, what do you guys do? Jim Bob makes AIs that runs off of the screen. And what can I help you with? I want to talk to a representative. Okay, sure, I understand that, but what do you want to talk about? This, that. You can have full-on conversations because it is a large language model. It understands actual language input that you give it, but it also is provided, or it's shrunk down to the size of something that only you need it to work with, right? Assume that your knowledge base is this big, right? You know about cars, you know about rockets, you know about swimming, you know about soccer, you know about music, you know all of these things. Do any of those matter when you are at an exam? You shift your context to what is important for that exam, is exactly what ReAct does. A large language model might know a lot of things, but you switch it to just know what you want it to know or what to respond, or what tools to, or you equip it with tools to answer the way you want it, per se. Any questions, guys?
How would we get this to maybe say, for example, go on the web for us, or like use a browser?
How would you get it to go? Okay, so currently, this app is being hosted. Where is it? Where is it? So the function that we made down here, or the reason we're using Fast API is because we want to have a web interface. If you look over here in the CLI code, what we are doing is pretty much sending a, where is it? Sending a post HTTP request to this place. Now, if you open a browser, can you guys see my Chrome? Wait, yes, okay. I can go to localhost and what was the port? 8,000? What is the port? 8080. Okay. right? It says detail not found, right? If I do chat, it will also say method not allowed because I'm not giving it anything, right? And obviously, you cannot put a JSON within this, but what you can use is something like Postman to create that post request for you. So, what you are doing, I am going to try to hide these as much as I can. Okay, so what you will need to do is put your IP in here. Well, let's say localhost 8080, right? And if you give it the parameters right, or not the parameters, the body right, it should do exactly the same thing as you're asking it to. So what are we asking over here? We're asking for a message to be hi there and a history to, let's say, be, how do we define history? Empty list. Empty list. Okay, so technically, right? Technically, this should work. Unless I'm doing something wrong. Oh, yes, okay. No. It is spinning. Hello, how can I help you today? See, this is the web interface. But since we did it with JSON, it would be a little different. If you want to take this to web, only thing you will need to do is create a web interface and link this internal API to your application. So whenever you press send, it will send the message and the history within that context. Does that answer your question?
Yes, thank you so much.
Okay, sweet, 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 sweet. All right. So we have less than 10 minutes left. I'm going to stop running these, but do you guys have any questions? No questions. All right. Two things I want to talk about. I would like for Jason to go more in depth about the prompting and the tools that you can create and can do for this matter. And secondly, the more important thing is next workshop. So in this workshop, we learned how to use a already made model, a already hosted model, like OpenAI, to make this thing work. Next week, we are going to run this completely locally. And this is not OpenClaw. This is not uh what did they change it to? What did they change the name to? Does anyone know? Moltbot or
It was
something?
OpenClaw, but Mopop was like the middle
OpenClaw and
one.
Moltbot. Yeah, yeah. So it's not going to be like that. It's not an application that you run. You're creating the application yourself, and then you choose what model you're going to use from the thousands and thousands and thousands of model that is running and is up on Hugging Face. All of the open sources that you want based on your hardware, you can choose based on what you wanted to understand, and that is that. We're going to self-host it next week and create more advanced tools that is actually like useful and not like examples like popular places and cities and capitals. But yeah, I guess that's it from my side. My guy Jason, are you here?
Yes, I'm here.
Yeah, all right. Do you want
Yes.
to move over to this guy?
Yes. Yeah, so I will go more in depth probably next week. I'll have more like uh I guess in-depth slides on like the different prompts that you can give their your React framework. But for right now, I think I'm just gonna go over just like a reminder, a refresher of every single part of like the things that we've gone over today, just to like refresh everyone's minds on like how everything works again. So, going over the prompt again for the actual framework, it includes the reasoning that, we would have, that we would give it to be thinking about, and then the action that we would want it to be doing. And then we can go over to the next slide. Yeah, and then so again, like going over what Suresh was saying, this is an example of like the tools that we would be using. So like we'd be going over like the capitals and everything. It defines the results that the call function is going to have. So like he was saying, to be more specific about what you want your LLM to use, we'd give it, the basis of the frameworks that we wanted to go over. Not frameworks, sorry, but the basis of like the prompts that we wanted to go over. And then next slide. All right, cool. And then he defined like the popular places, and then the other cities, again, just related information that when we actually do the call to the agent, when the agent actually does these calls to in this case, the open API, it will like get more information surrounding these things. So when you ask about it, it's going to be more in depth. So, and then next slide, sorry. The actual functions or the tools themselves that the agent will be using itself, as defined in the dictionaries from the previous slide. This is what the agent's actually going to be using to uh, prompt the open API calls. Again, next week I'm going to be doing more in depth about the different tools that you can actually give it and their different functions. So, like Suresh was saying that if, for example, if you wanted to do a call on or send a message on Discord, or if you wanted to send an email, even a link through your Gmail, you would define that in these functions here given, and then based off the dictionaries that you defined earlier, be more specific about how you want it to go about that process. But again, as a refresher, this is like all the definitions. And then next slide. And then this would be the tools, the actually was saying like the JSON output that he gave it. So it gives like the function, the name of everything. Um, yeah, and then it just basically is just a description of how you want it to be going. And then the next one. Yeah, and then it again just defining and doing the argument parsing for the different functions. And then last one. And then yeah, all this to be moving on to the query, which is just the reasoning loop that keeps going. It records all the conversation loops, saves them as observations, and then it keeps looping back around with reason and thought instead of just having a single prompt. But yeah, and then last slide. All right, thank you guys so much. I appreciate you guys coming. Um, just a little announcement. Next week, or we're gonna be having a GBM from a guest speaker that's from the industry. So make sure you guys come. We're just gonna be on Zoom and in person. Unfortunately, the guest speaker cannot come himself in person. So if you can't make it to the room itself, then no worries. We'll be having the Zoom link posted. And thank you guys so much for coming. And I'll leave it to Surush for any last minute things he wants to say.
Thank you, Jason. I appreciate you for going over those details. That should have been done before I actually did the tools and prompt. So that's my bad. I apologize. However, I guess we can, it leaves more space for next week because it's going to be exciting, y'all. It's going to be genuinely different. It's going to have a lot more to cover and actually use. So I would hope you guys either join next week or if you guys cannot join in person, to watch the recordings of this one and the next one to get more involved. And it is, I believe, something that will change the way we use AI and self-hosted AIs in specific. If you guys if have any questions, please feel free. If not, that is all we have for this GBM. Thanks to David, thanks to Jason, and thanks to all of you. Thank you, all of you, for joining in tonight and tuning in with us. It is super late. It is super late, but I appreciate all of you.
Yes, and thank you, Surush, for doing the whole walkthrough and the whole explanation. I think you did wonderful. So
Thank you.
thank you guys.
Thank you. Thank you.
But yes. And then Surush, would you be okay with posting the repo
Absolutely.
as well?
Yes.
All right, then
Yes.
perfect. Then you guys can also follow through with the repo along with the slides as well. So
Thank you all.
thank you guys.